Hello and welcome to another video from Blender HD. My name is Jonathan Lampel, and in this video I'm going to be going over cycles settings. So this is something that I'm sure you might have heard a lot about, but when I was looking it up and I had a few questions about it, I didn't find any video that had all of them explained all at once. They were just little bits and pieces here and there, and you just kind of have to scavenger hunt to find your answers. So I decided to make this one video to explain the sampling, volume sampling, and light paths as best I can. So this is mostly aimed at beginners, but if you have some experience, you might pick up a few tricks along the way. So let's go ahead and get right into it. First, I'm going to start out with this sampling panel. So right now, if you set this to rendered view, we can see our preview in the viewport. And the first setting I want to go over is the samples, and that's very simple. This just defines how many times Cycles is going to calculate the rays that are coming out of the camera. So when you have this to a low value, say like 2, you're going to have a very noisy render, and as you increase this, and of course you'll have to wait for it to calculate, but it'll increasingly become more and more smooth. So if you have a very noisy render, be sure to increase the render samples. Of course that does take a lot of time, so it's always a balancing act of how many samples you actually need versus how much time you have. Next over here we have the settings for seed, clamp direct, and clamp indirect, and the seed gives us a random noise pattern. So right now the pattern is set to Sobel, and you can change that to correlated multi-jitter if you know that's the older method. This one is a little bit more smooth, I believe, but this randomizes the pattern, and let me show you an example of that. So here we have a video of a cube just simply moving across a plane with the default seed value set to 0. So as you can see, the noise pattern doesn't move with our animation, and it looks very fake. So what we can do is actually animate that seed value so that it now looks like this, which is still very noisy and grainy and rather annoying, but if this is just a very extreme example. This gives us a more film type look, so it doesn't look quite as fake, although obviously it's still very noisy and we'd want to increase the samples. It helps us get a better animation. Okay, back into Blender. We have our clamp settings. We have clamp direct and clamp indirect, and I have a couple pictures explaining this. So here we have our normal clamp settings. They're both set to 5, clamp direct and clamp indirect. We have a light down here in the bottom right corner. It's reflecting off of this mirror and onto this plane. So in this picture, they're both clamped, 1 and 1. And what that does is it decreases the higher values of these lights and sort of squishes down the tonal range of our image from our emission. And so you can see that it clamps those lights down so that they're not quite so bright. But of course there's separate settings for direct and indirect. So in this next image, I'm only clamping the direct light and not the indirect. Okay, so the direct light is from our lamp over here, and you can see that there's a big difference to where if I flip between the two, you can see on the walls, on the floor, and in the mirror, those are changing dramatically. So the direct is anywhere where the ray is coming out of the camera and the light is bouncing back directly. So you can see that this object here is not affected because the ray is bouncing off the mirror and onto it, and so technically the ray is coming from the mirror and not from the light. So that's an indirect path because it's not coming straight from the light source. So then if we clamp the indirect instead, now we don't have such bright values on this where it's coming from the mirror, but everywhere else we have that nice bright light. So you might be wondering, why is this even useful? But for instance, if we have some noisy fireflies or whatever, you can see those really bright values, little bright dots right in there. Sometimes those stick around a bit too long, and if they become troublesome in very specific circumstances, you can set the clamp settings here, and that'll get rid of those fireflies. So another thing that you can do with these sampling presets is change from path tracing to branched path tracing. And this gives us a little bit extra control and helps us get faster renders. So we have the same settings here for seed, clamp direct, clamp indirect, and we can also square samples, which is something that we could do over here as well. Let me just show you that really quick. If we check this box, it's going to take these values and square them so that 10 is going to equal 100 samples, 11 121, 12 144, and so on and so forth. It's going to square the number of samples. And the reason this is handy is just so that we can work with small values and not have to constantly put in, large values. This comes in handy with branched path tracing, where our samples are separated out between the types of shaders, or types of bounces is a better way to put it. So we can separate the diffuse, glossy, transmission, ambient occlusion, mesh light, subsurface, and volume. So our diffuse, we can give those more samples, so our diffuse objects are going to be less noisy. Let me set up an example scene really quick. So we can say, for instance, we have a diffuse object there. You can see it has a diffuse shader. Let's duplicate that, and I'm going to give this a glossy shader. Okay, so we have our diffuse and our glossy. But if I set our AA samples, anti-aliasing samples, that increases the total number overall. So let's leave that down to 1 and uncheck that for now. You can see also our totals down here, just in case you don't want to do the math, so this is very handy. So we only have one sample going on, and then it's going to add these to the anti-aliasing samples. Or multiply, it's going to multiply them. So right now we have 3 diffuse samples, and we can increase this. So we can have a very smooth diffuse shaders without having to worry about all of our other shaders that might take more time, for instance our glossy shaders. So you can see that we have some glossy noise, and we have usually more glossy noise than we do diffuse noise. So a better way to do this is maybe to say 3 diffuse and then increase the glossy amount. So now that we have 8 glossy samples and 3 diffuse. Essentially, what I'm trying to say here is that however many you set this to is going to only affect those areas with that type of bounce. So the diffuse comes from the diffuse shader, glossy from the glossy shader, etc., or things that use the glossy shader. For instance, the glass shader also has a component which is glossy, so it's anything that is reflective like that. We have transmission as well, and that's any ray that goes through an object and comes out the other side. It is now a transmission ray. There is an ambient occlusion, which you can turn that on in the world settings here, ambient occlusion, and that's going to add light to our scene from everywhere except the corners and little crevices and things like that. So you can separately set the amount of ambient occlusion samples. Mesh light, so any light that's being emitted from a actual surface from the use of an emission shader. So you can see that we can change this to emission shader, and that's going to affect how many samples are concentrated in that area. And of course subsurface and volume. So this is very handy that we can specify exactly where we want our samples to be. So for instance, if you're rendering a car, you'll probably want a lot more glossy samples than your diffuse because those areas are going to be more noisy. So I really encourage you to play around with these and take a look, because it can definitely increase your render times. Moving on, we have volume sampling, and I have a few more pictures to show you for that. So the first option that we have is heterogeneous step size and then max steps. So these only apply to heterogeneous volumes, and that means that they're made up of more than one type of mixture or more than one substance. So homogeneous is something like if you add volume to your world and you have this sort of fog effect, or if you have any sort of volume that doesn't have a texture applied to it or anything like that. It's just the same all the way through. So heterogeneous is where things are mixed up, and a good example of this is fire and smoke. So let's take a look at that and look at the step size. So right here we have a step size of 1 and it's set to 150 samples. So this is a really large step size. The default is 0.1, but I increased it all the way to 1. Here we have a step size of 1, and you can see exactly what's happening. We're adding more detail, more form or volume as it seems. It's not making it more thick, but it's fleshing out that form with the light. And it's basically telling Cycles how many times or how small the details can be, excuse me. So you can see that we can only get large details here, but the details are now being able to be smaller and smaller. And if we set this to an even smaller value, say 0.001, we don't have a lot of difference. But if you had a bunch of small details in your smoke simulation, then that might be helpful. But the big difference here, since this is set to 0.001, which is a very small value, this render took 55 minutes. Okay, 55 minutes, while this one took 11 minutes with only 0.1, and this one with a value of 1 took 2 minutes and 11 seconds. So this is going to most drastically increase your render times the smaller that you have it set, but the smaller that you have it set, the more detail you can have, and the more thick that your smoke will appear to be. So it's a balancing act of determining how small you can go without losing detail or compromising how much time you have for your production. Next we have the max steps. So I have this image here, and you can see that I have a very thick smoke, and I have the max steps set to the default of 1024. And this render took 3 minutes at 150 samples. So the max steps is telling Cycles how many times it can go through the volume and how many steps it can take inside that. So let me show you this next picture where we have a max steps of 50 and absolutely nothing changed. And that's because it doesn't need 1024 steps, but it has about the same render time. So it's not really hurting anything to have it so high, but it's not really cutting anything out. But here we have a max steps of 10, and it's sort of clipping the volume. It's taking out parts of the actual volume itself. So this rendered a lot faster at 1 minute and 15 seconds, but we are losing some of that detail. So why would we use this? Well, for instance, if we had a very, very thick smoke and we set the max steps to something lower, that we can still get the detail, so we're not seeing visually any difference. However, it's just enough to see everything. What it's going to do is it's going to cut out what we can't see and not calculate it. So the very inside of the smoke is going to be erased, because you can see that the areas where it's very thick are the parts that are going to be cut last on the outside. But the inside that we can't see is going to be cut out, and that's a good way to decrease our render times. So this isn't always useful. It doesn't decrease the render times drastically in all situations, but it's a good tool to have and to keep in mind if you're working with smoke. So now that we have the volume sampling, let's finally look at our light paths. So I have a couple scenes set up here. The first one is a series of transparent planes. And we're going to take a look at these transparency maximum and minimums. So let's go ahead and look at these rendered. You can see that they just have a transparent shader with just a little bit less value so we can see where they are. But we're getting this large black box, and that's because we're only having 8 transparent bounces. And so since each plane has two sides, we're only going to be able to see through 4 planes until it gets basically stuck and terminates the bounce, and there we get the black. So let's increase the maximum, and as we increase this maximum, we are going to shrink that black box. But we get this sort of in-between effect where Cycles is saying, okay, the minimum is 8 and the maximum is 27, and it tries to blend those two together. So if you want to get rid of that, you can also increase the minimum up to the maximum. So let's set this much higher. I think all we need is 50 for this. And now you can see that we have a nice smooth render where we can see through all of our transparency. So this is a fairly extreme example. Normally you don't need 50 because this is going to increase render times. But if you're just getting that black box in anything, it's something to definitely be aware of so that you can get rid of it and get these nice smooth renders. Next we have this checkbox underneath for transparent shadows. So when we have that checked, you can see that the light is treating this as a transparent surface, which it is, and giving us a shadow that's not completely black. But if we uncheck this, it's going to treat this as a solid surface and not give us those transparent shadows. So of course most of the time we want this checked, but unchecking this will save a little bit of render time, so it all depends on what your needs are. In this next example, I have something set up to show reflective caustics and refractive caustics. So if we turn this sky down, we can see this better. I have a light over on the right, and then here I have a cube with a glossy shader, and this gem here with a refraction shader. And you can see that there's light coming off and spilling onto these tiles here. And when it's coming from the reflection shader, it's bouncing off and hitting the floor. When it's coming through the refraction shader, it's going through and then spilling onto the floor. So these refraction caustics is basically, say you have a glass of iced tea and you set it down on the table and you can see that light being concentrated. It's because it's taking the light and bending it in a different direction, so some parts of it are going to be more concentrated, and that's the effect that you're seeing here. Same thing with a mirror. If you have a mirror and if you shine it in somebody's eye or whatever, or if you have a curved mirror and it's going to spread out a light on the floor. I'm trying to think of a really good example of this. Car tires or car wheels, the rims. If you notice, sometimes it'll reflect a pattern onto the floor or the concrete, whatever. And so that would be an instance of reflective caustics where it's bouncing off and then hitting the floor. So we can turn these on and off one by one, so reflective caustics, and we can also turn off refractive caustics. And the reason we might want to turn these off is that they take a lot of time to clear. So if you do need to speed up your render times and you don't want that much noise, you can turn these off. So you won't get as a realistic result, but you'll get a lot faster render time that's more noise free. We can also filter the glossy, so that's going to affect these caustics here. So as we turn this up, it's going to smooth those out and remove them. So this is helpful in getting rid of noise, but you're going to lose detail in your reflections. But if you still want a little bit of those, or for whatever reason your glossy surface is just too noisy, so let's say for example I turn up the roughness so it's a bit smoother, and then I play with this, the higher I turn this up, the more detail we're going to lose inside of there. and it also reflects these caustics as well. So I'll turn both of those off for now. In this next example, we're going to look at bounces. So we have a maximum and minimum, and this is just an overall control over all of these. And the first one is diffuse. So even if we have this set all the way to 0, we still get color from our cube. So this does not affect the diffuse object. What this does is affects the objects surrounding the diffuse object. Think of this like global illumination. It's taking the color and spreading it out to the objects around it, like it would in real life. So if you have a white piece of paper at home or wherever you are, and you take a colored object and put it on that white piece of paper, you'll notice that even though the piece of paper isn't really a mirror or shiny or anything, it's still going to get some of that color. And that's the same thing that we're seeing here. So everything in the world is at least a little bit reflective. And as we turn this up, we can simulate that. So on this ground, you can see that we have a little bit of red, and on this cube here. So basically, it's reflecting that in the way that a real-world diffuse material would. But it's only affecting the floor and this cube here. So it's going to bounce one time. Okay, but if we increase that to, say, 2 or 3, we can see little traces of that red in this object as well. And it's not very obvious, but they're there. And so what that's saying is, it's not only bouncing off. Here, let me just draw this in the 3D viewport. So the first bounce is going onto the floor and onto this cube here, but then it's bouncing from this cube onto this cube over here, and that's going to be the second bounce. And the higher you turn this value, the more objects it can bounce off of. But really, you don't need that many. So usually 3 is as high as I'll put it, because the higher that you have these values, the more your render times are going to be, and the longer you're going to have to wait. So I think 3 is usually pretty good. However, if you have this down to 1, it'll give you a direct lighting like you would get in Blender Internal. Similarly, we have our glossy bounces, and this is a good example. I have 2 mirrors facing opposite each other. I need to add some color to this world. Okay, so we have 2 mirrors facing opposite each other, and they're going to reflect each other into infinity. I'm sure you have been in a place where you have 2 mirrors facing each other and things just get smaller and smaller and smaller like a tunnel, and this is that same effect. But you can see that at the end we get this black box right there, and that's because after a certain amount of bounces, 4, after it bounces around 4 times, it's going to terminate to that black color. So the higher that we turn this, the more that we can get. But once we get above 12, it's not going to matter, because remember, we have the maximum and minimum values set, and so it's going to clip these values at 12 and 3. So let's set this to 100, which is quite a few, and then we can turn our maximum value up to 100 as well, and we still have that minimum sort of gradation, and we want to turn that up. So we're going to turn that up really high. So this is unnecessarily high. You generally don't need any more than, say, 5. So it totally depends on where you are. But the higher you set this, the more bounces you can get. And so if you have that annoying black box, or clipping black shadow, you can try to increase this and see if you can get better reflections. In this case, we do. We can now see this tunnel going all the way down to infinity on both sides, and it's very cool. So remember that this is just the amount of times that the light from the camera can bounce off of these objects. Next we have transmission. So in this scene, I just have objects inside of objects, and these have a translucent shader because a transmission bounce is something that is a ray that passes through an object and comes out the other side. So translucency is a good example of this, where the light is coming out the other side, and while it's inside and coming out, it's then transformed into a transmission ray instead of any other type of ray. So we can render this, and if we turn this all the way down, you can see that we get a completely black object because there's something inside of it that's not allowing the light to pass through. Once we turn this up to 1, we now get a lighter object. It has some color, but it's still very dark, and so as we increase this, the light can bounce through those objects inside until it comes all the way back out the front. So generally, we don't need this to be extremely high because, if you have a diffuse object, there's not really any light going through it, and so you're not going to notice. But if you have things like a lot of leaves with translucency or subsurface scattering or things like that where light is passing through lots of objects, you'll want to turn up the transmission. Lastly, we have volume, which is exactly the same. So normally this will be set to 1. If you have this set to 0, you'll get a very smooth render. It'll clear up extremely fast. Actually, there won't be any noise at all, and so that's really cool. However, you're not going to get any sort of depth. You can't have objects inside of objects like I do here, where there's lots of volumes together. So once I turn this up, the light can bounce through more of that volume, but of course it's going to be very noisy. And I also have my volume set to 1, so I'll change this back to regular path tracing just so it can chew on that for a bit. So you can see that the higher I place this, the more that the light can pass through that volume. So what it's not doing is lightening up the volume, because that is actually defined by this color here. So don't mistake it. So even though I might get a similar result if I had this turned down, what it's actually doing is allowing the light to bounce around more inside of that volume. And so you can turn this as high as you want. But remember, all of these settings, the higher that you turn them, the longer your render times are going to be. So all of this is one big juggling act of time versus quality, and it's up to you to decide exactly where you want that line to be drawn. So thanks for watching this video. I hope you learned a lot, and I'll see you in the next one.